Okay, let's do a couple from each section here. We'll do number 2. Number 2, the first thing you want to do is factor. So if I factor the top, we have a difference of 2 squares. So that would be r minus 8 times r plus 8 divided by, on the bottom, I can take out a GCF of 4, which would leave me with r minus 8. So before I cross anything out, let's go over the undefined values. So here, r cannot equal, we look at the bottom, positive 8. So then I can cross these out and I'm left with r plus 8 over 4. So there's my answer along with my undefined value. Number 3, I can't do anything to the top, but on the bottom I can factor this. So I have 1 times negative 56, which is, you could list your factors, but that's going to be 7 and 8, a negative 8 and a positive 7. So n plus 7 and n minus 8. Again, before I cross anything out, let's do our undefined values. So n cannot equal negative 7 from here, and n cannot equal positive 8. Cross these out. There's a 1 left on top and an n plus 7 on the bottom. So there's my answer, and there's my undefined values. Okay, the next section, all you have to do is the indicated operation, so you don't have to find the undefined values here. So we'll do number 5. So number 5, we want to factor first. So I'm going to factor the top to be x minus 4, x plus 4, a difference of 2 squares, divided by, on the bottom I get x minus 4, x plus 3, times, up here, x plus 3, x minus 1, over, and right here I can just take out a GCF of 2, so I have x plus 4 left. So now cross out things that are common on top and bottom only, x plus 4, x minus 4, and that's all. So the leftovers, we have x minus 1 over 2. And that would be our answer. Okay, number 6, when you have one like this, you want to go ahead and put everything together on the top and the bottom. I think it makes it a little bit easier. So we'll multiply the numbers, so we get 30. Then we count our x's. I have 1 x here, 3 x's here, and 1 here. So that would be a total of 5 x's. Then I have 1 y plus 4 y's plus another 1. I have 6 y's, and then I have 1 z. Divided by, on the bottom, 3 times 2 is 6, times 3 is 18. We have a total of 4 x's, 4 y's, and 2 z's. So now we want to simplify. 30 divided by 18, they're both divisible by 6. So 5 and 3. For our x's, we have 5 on top and 4 on bottom. So we subtract would be 1. 6 y's and 4 y's would leave me with 2 y's. And I have 1 z and 2 z's, so it would leave me with 1 z on the bottom. And that would be your answer. Okay, let's do a division one. We'll do number 7. So, nope, sorry, number 9. So on division, remember you have to flip this second fraction. So I'm going to flip it and cross this out. Okay, so now let's factor. This top left would factor to be x minus 4, x plus 2 over x minus 5, x plus 3. Now I'm multiplying. So here I can just take out a GCF of 2x, and I'm left with x minus 5. Here I can take out a GCF of 2x, and I'm left with x minus 4. So the x minus 5's cancel, the 2x's cancel, the x minus 4's cancel. So I'm left with x plus 2 over x plus 3. Okay, let's do we'll do number 10. It's the only addition one. So for adding and subtracting, you need the same LCD, or the same common denominator. There we go. So this is going to be x plus 3 and x minus 4, and this one we just have x plus 3. So our LCD is x plus 3 times x minus 4. This one has both pieces, but this one is missing that x minus 4. So we have 3x plus 2 times x minus 4 over the LCD. If I simplify that, we get 3x plus 2x minus 4 over the LCD, which reduces to 5x minus 4. Oh, that should be an 8. Sorry about that. There we go. Over our LCD of x plus 3 and x minus 4. Okay, on the back, let's do number 12. Now the thing to be careful, extra careful about on subtraction is the minus sign has to distribute. So if this was like two things, like maybe x plus 2, it would distribute to both of them. So that's a very simple mistake a lot of people can make. So this factors to be x minus 5, x plus 5. So this one is missing the x minus 5. So if we write that out, we have x times x minus 5 minus 50 over the LCD. And if we distribute that, we get x squared minus 5x minus 50 over x minus 5, x plus 5. Okay, 13, we'll do number 13. Okay, so the transformations, it just wants you to go from this 1 over x to this. So it's saying, well, what does the plus 3 do and what does the minus 5 do? The one on the denominator is always opposite. So it's going to go to the left 3, and then this one does what it says. This one moves up and down. This is left and right. So then this one would go down 5. Now the vertical asymptote from this one just comes from the bottom, same thing as we did before, x equals negative 3. The horizontal comes from this part, so y equals negative 5. Okay, your domain always comes from the VAs and the wholes. The range, the x in the whole. The range comes from the HA and the y value in the whole. So in this case, x cannot equal negative 3. And in this case, y cannot equal negative 5. There's no whole to worry about here. Okay. Let's look at number... We'll look at number 16. Okay, so, no, I want one that has multiple pieces. Okay, we'll look at 17. So 17, you would want to factor the top. So x minus 12, x plus 3 over x minus 3, x plus 3. Okay, so if you do the HA first here before you even factor, this is exponents are the same, divide coefficients. So the exponents are both a 2 and the coefficients are a 1, so 1 divided by 1 is 1. Okay, cross out the common factor and you'll get that graphing sheet. So cross out the common factor, that leads to the whole. So if you solve this, you get negative 3 as the x value. I should put that here. To find the y value, you plug it into the leftovers. So I would do negative 3 minus 12, I'm putting it in right here, divided by negative 3 minus 3. So that's negative 15 over negative 6, which reduces to, what, 5 over 2, or 2.5, either way. So on your graph then, you actually have a whole, negative 3, 2.5. Okay, the VA is what's left on the bottom. So x equals, remember we changed the sign there, so positive 3. The zeros, now if you can't remember this, you should be graphing this in your calculator. So let me show you what that looks like. If you graph this, you go to y equals, on the top make sure you put it in parentheses, x squared minus 9x minus 36 divided by x squared minus 9, and you graph it. Okay, so where it splits here, there's a VA, and you can look like if you drew a line here, it looks like it's right at positive 3. So we have x equals 3. Now the zeros are where it touches the x-axis. So if I go, you can't really see it here. It looks like it's going out. So if you go to your table and you look for where y is 0, we know it's going out. So there, 12, 0. Now how you find it without a calculator would be you just take the top. So this would be 12, 0. Okay, the y-intercept is where the x is 0. So if you want, you could go, whoops, we could look at the graph, and it looks like the y-intercept is maybe at 4 or 5. So let's go here and look. Well, where x is 0, sure enough, y is 4. So how do you find that without a calculator is you cover the x's and divide. Negative 12 divided by negative 3 is positive 4. Okay, the domain comes from the VA and the x value of the whole. So x cannot equal positive 3 and negative 3. The range comes from the HA, so y cannot equal 1, and the y value of the whole, which would be 2.5. Okay, remember, you can always graph this in your calculator to get a lot of this information. It's a multiple choice test, so you're not ever going to have to actually draw the graph here. Okay, number 18. Which of the following equations could represent the given graph? Well, the first thing to look at is you know that the VA, which is this one, comes from the bottom. So if this VA is at x equals positive 3, you know on the bottom you must have a negative 3. So we could have this one, or this one. So let's first cross out that option. Okay, the next thing you could look at is the top is the 0. So right here, 1, 2, 3, 4, 5, 6, that point, 6, 0, comes from the top. And it's a positive 6 here, which means it's a negative 6 on this. Now, if all else fails, use your calculator and graph that. So if I plug that in to y equals, and I say x minus 6 divided by x minus 3, and I graph it, it should look like this picture. So you could graph all 4 of them if all else fails and say, well, which one matches? Okay, number 19. At what point does that graph have a hole? Okay, now first of all, we need to review how do you factor this with a number in front. Okay, that's important. So 3 times negative 2 would be negative 6, and list your factors. So 1 and 6, 2 and 3. The 5 is negative, so we make the right side negative, the left is positive. So which pair adds to give us negative 5 would be this pair. Because there's a 3 here, you have to divide by a 3x. So negative 6 and positive 1 divided by 3x. This one doesn't simplify, so we write that 3x plus 1. But this one simplifies to be negative 2 over x, so x minus 2. And then on the bottom, we just have x minus 2. So in order to find a hole, it's where there's a common factor. So these cross out. The x value of the whole is, if you were to solve this, you would get positive 2. So positive 2. The y value comes from plugging it into the leftover. So we have 3 times 2 plus 1, which would be 6 plus 1 is 7. So 2, 7. Okay, number 20, what are the asymptotes, domain, and range of this function? So let's start with the asymptotes. The horizontal is that goofy saying, Bobo Botan eats DC. Okay, so if you look at the exponents, you have a 1 on top and a 1 on a bottom. The exponents are the same. We divide the coefficients. 1 divided by 1 is just 1, so y equals 1. The vertical asymptote comes from the bottom, so x equals, this is a negative 5, so positive 5. The domain, remember, for the third time, matches the VA and the x value of whole, so x cannot equal 5. and the range matches the HA and the Y value of the whole. So Y cannot equal positive 1. Okay, 21. Factor the top, x minus 3, x plus 3, over x plus 5, x minus 3. These cancel, so the leftover is the VA. So the vertical asymptote is x equals negative 5.